We come to question number 14, where we are given a function fx which is having two different routes for the paths that it follows from x less than equal to 0 and x greater than 0, and we are asked to find the double differential of the function at the point x equal to 0. Now fx is equal to x plus a whole square for x greater than equal to 0 and x plus a whole cube for, this is less than equal to 0 and x plus a whole cube for x greater than equal to 0. So the first differential of the function x would be 2x plus a for x less than equal to 0, and this would be 3x plus a whole square for x greater than 0. And the second differential of the function would be 2 for x less than equal to 0, and this would be 6x plus a for x greater than 0. Now, in order for the second differential to be existent at x equal to 0, both the left hand side and the right hand side derivatives have to converge. That means at x equal to 0, 2 should be equal to 6 into x equal to 0, that is 0 plus a. That means 2 equal to 6a, or a is equal to 1/3. So option B should be the right choice, that it exists at x equal to 0 for exactly one value of a, which is equal to 1/3.